Alright guys, we're getting into modeling exponential equations to fit a real-world context. So we've looked at exponential functions. To review, that's y equals a times b to the x, where a is going to be our starting rate, our starting value, and then b is our multiplier. Okay? And so there are two types of exponential functions. They both have the same form. But there's exponential growth and exponential decay. And the value of b is what kind of changes from growth to decay. If b is greater than 1, okay, so if b is greater than 1, then we have exponential growth. Okay, we're multiplying by a value greater than 1, so our numbers increase. Okay, if b is less than 1, then we have exponential decay. We're multiplying by a number less than 1, so our value, our total value is getting smaller, because that's what happens when you multiply by a decimal less than 1. And so if it's growing at a fixed percentage, a lot of times in these real-world contexts, we're going to talk about percentages. Then we have what's called R is going to be our rate of growth. And so if it's exponential growth, then we're going to take b to equal 1 plus that rate. Okay, so if we're growing at 20%, then we're going to take 1 plus 0.20, which is 20%. So our b would equal 1.2. Okay, if we're growing at 6%, then we're going to take 1 plus 0.06, which is 6%. So our b, our growth rate, our multiplier would be 1.06. Okay? If we're decaying, then we take b is going to equal 1 minus that r. Okay? 1 minus that r. So if we're decaying at 20%, then we're going to take 1 minus 0.2, and our growth rate will be 0.8. Okay? So that makes sense. Then our b is less than 1. We're keeping 80% of our value because we're losing 20% of it. All right, so in the same way, if we were decaying by 6%, then we'd take 1 minus 0.06, and we would be growing, or we wouldn't be growing, excuse me, we'd be keeping 0.94 or 94% of our current price. Okay, and you can see what growth and decay look like here on a graph. Okay, we've seen these before a little bit. When we're growing exponentially, and that goes up very quickly. We've seen these exponential growth grows even quicker than quadratics. A lot of us have said they look like quadratics, but they in fact grow much more rapidly than quadratics. And what this curve is doing is it's increasing, but if you look at the amount that it's increasing, the amount that it's increasing is actually increasing. So here, when we grow from here to here, that value is getting bigger each time. So if we look at the rise in the change in our y values, that value is increasing. So we call this an increasing increase. Okay, an exponential decay is kind of just the opposite. The amount that we're decreasing is doing what? It's decreasing. So this is called a decreasing decrease. All right, the amount that we're decreasing is decreasing. Okay, the amount that we're increasing is increasing. In linear equations, we said we had a constant rate of change. The amount that we were increasing was constant. But here we have different kinds of change. The amounts that we're increasing is increasing, or the amounts that we're decreasing is decreasing. Okay, so let's look at a couple examples. We have bacteria that is multiplying by splitting into new cells. Okay, so for example, one bacteria can double every hour. So this bacteria actually splits in half and it becomes 2 different bacteria. Okay, and then it splits in, each of those split in half and it becomes 4 different bacteria. Okay, and then each of those split in half and it becomes 8 bacteria. Okay, and so we have this exponential growth. It's doubling every time. So we're asked how many would there be after only 12 hours if it's doubling every hour. We're asked to write an exponential equation for the situation. So we need y equals a, some starting value, times b, some multiplier to the x. All right, well, we're starting with 1 bacteria, so that's y equals 1 times, and then we're doubling each time. And if we look at this in a table, if we have x, y, remember we always start at cycle 0. So when our 0 cycle, we had 1 bacteria. At our first cycle, after the first split, we had 2 bacteria. And after the second split, we had 4. After that, we have 8. So we're actually multiplying by 2 each year since we're doubling. So that's our equation. We're asked to find after 12 hours. Okay, so y is going to be the amount of bacteria, and to find that, we're just going to take 2 to the 12th power. Okay, so that's 2 times 2 times 2, 2 times itself 12 times. So we can figure out what that is. That's 2 to the 12th power. That's 4,096. So that's going to be y equals 1 times 4,096 bacteria. All right. Now, if we were starting with 2 or 3 bacteria, then we would take that 4,096 times the amount of bacteria we started with. Since we only started with 1, we're just going to take it times 1. So the amount of bacteria after 12 hours is going to be 4,096. Okay? So that's an example of exponential growth. If we look at exponential decay, a lot of times when people drive or buy new cars, they decrease in value very quickly. Okay, so this car is going to decrease in value by 20% each year. Let's say you bought a new car for $16,000. We're asked to write an equation to represent your new car's value over time. So this is an example of the percentage we were talking about here. So our rate of decrease is 20%, or 0.2 if we're talking in decimals, right? So our rate is 0.2. We're going to find b, and remember we take 1 minus our rate if we're decaying, if our value is getting smaller. So that's going to be 1 minus 0.2 equals 0.8. So that means we're keeping 80% of the car's worth each year. Okay? So if our equation here is going to be y equals, our starting value is $16,000, and then we're going to take that times 0.8 because we're keeping 80%, we're losing 20% each year. Okay, and so if we want to talk about the value of the car after only 5 years, we're going to take y equals $16,000 times 0.8 to the 5th power. Right? So I'm going to start by just taking that exponent, 0.8 to the 5th power. That's 0.32768. So that's going to be y equals 16,000 times 0.32768. All right, so now if we figure out what that value is going to be by multiplying there, we take that value times 16,000, and we have 5,242.88, 524288. So we have 5,042, oops, what was that? 242.88 cents. So our car, after 5 years, is already decreasing to $5,242. So you've lost a great deal of the car's worth after only 5 years. If you think of you started with $16,000 car, and after 5 years it's only worth $5,242. That's why a lot of times people don't recommend buying a new car, because it loses value so quickly. Okay, so you guys can think about that. Try to use what you know now to answer this before the class problem. Johnny puts $100 into savings account and has an interest rate of 4%. He left it alone in the account for 12 years. You're asked to determine if this is exponential growth or decay, and then write an equation and use your equation to figure out how much money Johnny will have after 12 years.